Fantastic. So welcome everyone to the 5th Civo community meetup. For those of you that haven't attended before, usually we have a few different talks on varying topics. But today we've just got a single talk from Darren Shepherd, who is currently Chief Architect at Civo. He's the former co-founder and Chief Technology Officer at Rancher Labs, and he's a VIP in K3s as the founder, would you call it? The inventor? Supreme being?
Oh yeah, a creator. I don't know. Yeah, I created the project. I started the madness, and now it's actually managed by a lot of other people.
So hopefully everyone enjoys the talk today by Darren. If you have any questions, feel free to ask them as we're going, and if it fits in with what Darren's talking about, he'll answer it live. But after the talk, we're going to do a Q&A anyway. We've had some questions sent in before the talk starts. But again, any others that we don't get to while the talk's proceeding, then we'll just get to afterwards. So hang around to the end for the questions. Okay, over to you, Darren, if you want to share your screen.
Sure. Okay, let's see, share screen. Yeah, and so I'm planning on, let me share my screen here first. Desktop 1. Share. Okay, you should be seeing this PowerPoint, or I'm not presenting yet.
We can see your terminal.
Terminal, yeah, sorry.
Terminal. Okay, wrong one then. Okay. Well done. Oh, yep, that was the wrong screen. Stop share. We'll start on this one.
Darren's Bitcoin account suddenly comes up on the screen.
Yeah, pretty much. Yeah. I closed Slack and things like that, so hopefully. Okay, so yeah, okay. So now are you seeing slides? Yep, very good. Okay. So in general, so I honestly, literally, I just have one slide. I'm going to pretty much do all live demo, and so think this will be pretty ad hoc, kind of going through a bunch of topics. I really wanted to. It's like there's a lot of presentations and talks about K3s already out there. There's kind of a lot of beginner guides and how to get going with it, and I really wanted to do something where I kind of exposed a lot more of the details of kind of all the things we've done internally in K3s to make K3s so simple. And like, that's what I think at the end of the day, like K3s is kind of marketed in different ways. Like, from the Rancher SUSE side, we, have marketed a lot towards like Edge and things like that. But really at the end of the day, I think what makes K3s so popular is just that it's super simple. And it kind of just turns Kubernetes into this widget you can just kind of turn on and start consuming. You don't have to know a lot about how to administrate it and run it. And you can get it running in a bunch of different environments and like Raspberry Pis and stuff like that. And so in order to make that work in K3s, we've done a lot of little tiny tweaks and things to make it super simple. And they're not like, because it's kind of all this stuff's going on under the hood, it's not obvious what we're doing. And so I kind of wanted to expose, all of that stuff. So I'm planning on talking, let's see, probably about like 40 minutes. And as Andy mentioned in the beginning, if anyone has questions going through, feel free to ask them. And I don't mind answering things while we're going. Okay, so the topics I want to talk about is like the single binary. Like K3s is really just one file. It really is. Like there's an install script that most people install it with. But at the end of the day, it really is just one file. And I want to show what is encompassed in that one file. And then I want to talk about how we do some of the agent tunneling under the hood and why we've done that, how that's accomplished. Talk a little bit about the etcd management. And I'll show that setting up, high availability, three node cluster, just how easy we've made that in. Okay, then the agent client load balancing. So again, that's some internal thing that most people aren't aware of that we're doing and why we're doing it, how it works. Some of the little hacks we've done to CoreDNS to make some of the DNS simpler that just work out of the box. And then talk about, how we support manifests, like packaging applications through like manifests or Helms, image pre-polling, pre-population. And then last thing I'll go over is like, what are all the actual modifications we've done to Kubernetes? That's always like the big thing with K3s is like, well, what is this thing? Is it a forked Kubernetes? And how have we changed it and stuff like. And so I want to go through and I'll show you exactly where all the patches are. What I'll go, through each patch and say what it does, why we have that, so you understand what are the modifications we actually made to the core Kubernetes to make this all work. And you'll see it's surprisingly little. Okay, so let me see. So at this point, I'm gonna switch to a terminal. Because yeah, that's all I got for presentations. I'll probably go back to this slide just so I know where I am in all this. But so I've opened up. Let's see if maybe I'll make this a little bit bigger.
Sorry, Darren, just 1 second.
Sure.
Mikhail Kozorovitsky has raised his hand. I don't know if you have a question or if you've accidentally clicked the raise hand button, but if you have a question, just type it into the Q&A section and we'll read them out live to Darren so that he doesn't have to keep watching the chat.
Okay.
Thanks.
Is the size of the terminal good? Like people can read that? Okay, good. So yeah, so I've got 4 different tabs open here in my terminal here. If you care, I'm running Linux on my laptop. XFCE is my desktop of choice. So I've got 4 different tabs that are on 4 different VMs. So I've just spun up 4 VMs in the cloud. And so this should give us enough nodes to play with to kind of do, multi-node stuff. And we'll do that. Like I'll kind of demo all those things as we're going along. But so in all 4 of these machines have nothing on them. It's an Ubuntu instance. I just booted up. So we're just going to start right off the bat and install K3s. So the install script, we created the install script because first I want to talk about kind of the binary and stuff. So the install script to me is almost like a little bit, it makes me sad to a certain degree because it really obfuscates the simplicity of K3s. Because at the end of the day, like K3s really is just one binary. Okay. So what the install script is doing is it downloads the binary. So we grab the binary from GitHub, but like we grab the hash and we verify it, so it's secure and all that, you make sure you know what you're downloading. It puts the binary into place. It sets up these symlinks that are just going back to the binary. And then it puts in these 2 scripts. This is something like I'm hoping we can enhance K3s so we don't have these scripts anymore. We just put it into the binary too. Because the one thing that kind of bugs me is without the installer, you don't get these scripts, and they're really quite useful. I'll show those scripts later if you haven't used them. It'll come up as I'm doing things. So it puts the binary in place, and then it sets up systemd. So it creates a service file for systemd, and you'll see if you look through this, it's like none of this is super complicated or important. Like these are not even actually 100% required. This is just for certain environments where we might be missing those modules for some reason. We actually, even on startup, we'll try to load those. But you can see all the unit is really just doing is calling K3s server. So it's like the shell script, like, because people a lot of times ask for it, it's like, well, I want to do this with K3s, and there's like not an option in the installer to do that. And it's like, well, there's really not a lot of magic going on in the installer. It's just putting a binary on the host and setting up systemd. So I just wanted to call that. So it's like, because you can literally, like, if you don't want to use our installer, you can just copy the files around, and like any way you can get a file on a host and set up a systemd service, then it's fine. There's nothing magical about the systemd services or anything. Okay. So what is this binary? So this is like a massive binary. So the first thing you'll notice is like, well, we're symlinking things to the binary. So the binary itself is like, it's what's called a multi-call binary. And so if you're familiar with BusyBox, it follows the same pattern of like BusyBox. And the idea of a multi-call binary is you have one binary, and if you symlink it, if you like basically copy it or you name it something else, when the program starts up, it looks at, well, when the user invoked this, they invoked it as CTR. Therefore, I need to act like CTR, or this one I need to act like CRI-CTL, or this one I need to act like kubectl. So it's like when I type kubectl here, I'm in fact actually running, the K3s binary, but it looks at it and it knows that, it's looking at the argv0 name, and it knows to act as kubectl. So that's the first thing. Is the first layer is like K3s itself is a multi-call binary, but on top of that, here I'm going to shut down system D. Like I'm going to shut down, like right now, like when I started this up, it's like Kubernetes is already running. It just takes seconds to start K3s in general. But what I'm going to do here is I'm going to run. I'm going to stop K3s. The K3s kill all script. This will like make sure everything's dead. Like this will wipe out like all of any pods or interfaces. This kind of just cleans up the environment. And then I'm going to delete the var lib rancher K3s directory. So it's like if you ever want to wipe out the state of K3s, for the most part, like just shut it down, kill everything, and then you can just delete this directory. There's other directories that like the var lib kubelet or there's some directories in run that get created, but for the most part, none of those really matter that much. If you just want to wipe out the state, the core important state is in var lib rancher K3s. And if you wipe that out, then the next time it comes up, it'll be kind of in a clean state and it'll resync everything else. The other directories like var lib kubelet and whatnot. So what I wanted to show is this K3s, besides what I said is a multi-call binary, it's also a self-extracting archive. So when you first run K3s, so if I just say like K3s server -- help. Okay. Wait, okay. Var lib rancher. Oh wait, no, hold on. I'll do it the first time because I don't think if I run help, it doesn't seem to. Let me run. I'll just launch K3s once. Starting. Okay, let's see. I'm pretty sure on start it will. Yes. Okay. You'll see this directory, like when you first start up K3s, the very first time, you'll see a message like this where it's saying preparing data dir in this big long hash. So if you look in here, this directory that it created, data, this hash is a hash of the content, and then the symlink is the symlink to the current data that we're using. Because if you put in a new version of the binary with new content, it's going to have a new hash or whatever. But so when this thing starts up, we actually extract out all of this crap. Okay. So K3s itself actually includes an entire user space for Linux. Like K3s has zero dependency on the OS, except for the kernel. Like all you really need to launch K3s in general is let me see, grep is pretty much like it's the sys proc and dev. If the system has the sys proc and dev mounts set up, that's all that K3s needs. Even to the point that like we have this Docker image. Let me see if I can show this. Oh, this is a little obscure because it's like the Docker image of like, if anyone's used like K3D or if they've done running K3s inside of Docker, the Docker image itself is actually the only contents of that Docker image is what comes from the K3s binary. So it's like, the reason why we did this is we wanted to just remove all possible variables of how this could fail. It's like we make zero assumptions about the environment except for you have a sane kernel and some sane mounts. As long as you have that, everything else we kind of bring with it. So I'll show you here. So it's like you can see a lot of this is just like symlinks because it's BusyBox. So if I just kind of look at what are the files, so you can see here's the stuff that we actually package. And most of these are dependencies of Kubernetes, and over time these have gotten less and less. And some of these actually are not even needed anymore. But like I'm not 100% sure we even need ethtool anymore. But so
sorry,
these
Darren,
are very, yeah.
Just a quick one. When you're typing the commands, could you just pause for a second before they run, just so that people can?
Oh yeah, sure.
Also, we've got a quick question, which we can get out of the way while I've interrupted you anyway. Your script that will uninstall K3s, a attendee has asked, will uninstalling K3s on masternode gracefully remove the worker nodes as well?
No, well, okay, well, it depends on like, so the uninstall script is like basically just it runs kill all, so it'll kill all of K3s and it'll remove the binaries. It does not interact with Kubernetes in any way. So it's going to effectively like just yank out the machine underneath the hood of Kubernetes. So there's no gracefulness to that. So if you want to drain the node or remove it, like that's the uninstall script doesn't do that.
Perfect. Thank you.
Okay. Yeah. I'll try to, as I type commands, be a little slower and explain them too. Okay. So what I have here is a list, like I'll kind of go through all these different files, why we package them. It's like ETH tool has something to do with setting the, kind of low level parameters on the interfaces like TX offload and stuff like that. So there's some obscure networking flows that used to use it. I don't know if it's used anymore. Block ID is used largely by this. That's to interact with the storage devices. So CSI and things like that are going to end up using block ID in some way. Container D shim, that's the container D. SOCAT, I think in the next version of container D we can drop this, but SOCAT is used for like whenever you do port forwarding in Kubernetes, it goes through SOCAT. So if you port forward a pod or a service or something like that, it launches SOCAT to forward around some of the bytes. Core utils is actually, that's a multi-call binary for let's see who actually symlinks to core utils. There's a main reason why we want, there's something I remember that's important for core utils. I think it's actually DU. Yeah, it's actually DU is the one that the core one of why we needed this. And this might be gone at this point. I think in the newer versions of Kubernetes, but DU was used by the internal metrics on the kubelet to detect how much disk was being used. So CAdvisor would call it. I think it has a pure Go implementation now. So maybe we can actually drop that one. Runc is a low level. So it's like, that's how you actually launch containers, whatever is runc. LOSAT, this is for setting up loopback devices. I believe we're using this right now for some of the rootless stuff in K3s. So there's when you run K3s server, so I'm just going to run K3s server help here. There is a rootless flag, and this has been experimental for a while because it is experimental upstream. This is an ongoing effort, but it's like it is actually possible to run K3s without having root on a host. There's a bunch of little caveats. It doesn't just seamlessly work, and that's why it's experimental. But this is something, some effort we really care about, because like eventually when this, really gets all committed upstream, we want to make this really seamless. So just a regular user on a Linux host can run K3s, kind of for their own environment. But
Darren, can I interrupt you for just 1 second? Kind of speaking of upstream, there's a question from Paulo Cesar Soto in the Q&A, speaking of K8s deprecation of Docker shim, and he's asking, will K3s also deprecate Docker shim in 1.20?
Yeah. So we're on the fence here on this one. So it's like okay. So K3s right now, by default uses container D, but we have this parameter right here for Docker where you can just say -- Docker, and if you already have Docker on the host, then you can use it. So I don't have a concrete answer. So the Docker shim, Mirantis has said that they will support it. I don't think that's fully materialized quite yet. So we don't quite understand what's the work involved to be able to support this going forward. So I would highly suggest anyone that they actually like really move to container D if you can. That's just a better longer term strategy of not relying on Docker. But this one, we know that still a lot of users are using this. And if it's as simple as basically packaging and executing the Docker shim, I would be in favor of supporting it. But it's like that work hasn't fully materialized, and it's kind of a lot for us to commit to. Like, we just don't know if we can really commit to it quite yet until we see what Mirantis is going to put forward. I would say if Mirantis didn't step up and say that they were going to support the Docker shim, we probably wouldn't either. It's just we kind of have too much going on with K3s to then also try to create like the backward support for Docker, because there's some technical issues with supporting the Docker shim too. One of the reasons why they want to get rid of the Docker shim is because to a certain degree that's holding Kubernetes back, in that they can't evolve CRI features without making them work in the Docker shim also. And so there's a lot of interesting things that could be going on with Containerd and Cryo that they can't exactly accomplish because there's no approach with Docker. And historically, there hasn't been a lot of support in somebody maintaining Docker shim. It's just kind of been there. But now that Mirantis is stepping up, maybe some of these things will change. So TBD, I wish I had a better answer. But, a lot of this, like kind of what we do, like how we prioritize everything, is all up to like users. If enough people are like, we really want this, and this makes sense to users, then we'll do it. Okay.
Thank you.
So I was going through talking about some of the binaries and what not. Let me. Okay. So the LO setup, I was saying, I believe that's used for the rootless stuff, and there's a lot of binaries in here that actually are for supporting rootless, which is this slurp for NetNS, the fuse overlay. These support are for rootless. Some other little things. Pigs. If you're not aware of this, this is actually a massive speed up. Pigs is a parallel, like it's the GZ. It's a parallel version of GZ. So all of the content comes from Docker images is all tars that are gzipped and whatnot. And so by using this pigs instead of just like GZ, we can parallelize all of the decompression of assets, and it massively speeds up things. This is all under the hood used by Containerd. So Containerd will look at the host, and if you have pigs available, then it will use it. Otherwise, it falls back to, I believe, a pure Go implementation of GZ, which is significantly slower. So BusyBox is just like a bunch of random utilities. This check config script, if you haven't seen this is very useful. Like you can say K3s check config, and this command K3s check config is effectively just going to call this, which is a shell script, which this goes through and kind of validates that your host is good for K3s. So this is just something that really helps us with supporting users, because we do get, for the most part, any modern distribution of Linux is just going to work. K3s is just going to work seamlessly on it. But we do get people like, weird Gentoo setups or some ARM device where they've kind of compiled it themselves or whatever. And so, you can just run that to make sure everything's fine. More stuff that's in here. Start NSEnter. NSEnter is a utility. This is, I don't think it's so much used anymore. But it was, it's basically for entering and leaving namespaces. Maybe Rootless uses it. I'm not quite sure why we have NSEnter anymore. Because before that was mostly had to do with containerizing. If you ran the kubelet in a containerized setup. IPset. IPset is used for, actually, what are we using exactly IPset for? Because I think that, I don't know why IPset is there. Okay, so Charon. So there's two networking modes in K3s that we support that are encrypted. A lot of people aren't aware of this. So again, I'll just run server help, and then where's the parameter? I can't remember what the name of it is off the top of my head. Flannel, right? This one, Flannel backend. So we support the default is VXLAN, but we also support host gateway, none, which is effectively turn off Flannel. But we have IPsec and WireGuard. For the IPsec implementation, that is using StrongSwan under the hood. And so we actually fully package StrongSwan. so all you have to do to use the IPsec is you just say, flannel backend IPsec. We will configure SwangSong. We do the PSK, the pre-shared key. We manage, distributing that between the hosts and stuff. And that will do a fully encrypted network. WireGuard, we also support WireGuard, and this will hopefully become, like, right now, I want to basically get rid of IPsec and just move completely to WireGuard. But the only reason why is that at the time WireGuard was not upstreamed in the kernel quite yet. It now is, but right now we do not package the user space of WireGuard, so that we're not doing that. So I like to drop the IPsec and move to just WireGuard. And but anyway, so we include all the strong swan and all this stuff. So you'll see that in if I go back one directory here. Sorry, my little window's in the way on my screen. Yeah, so you'll see this in the etc directory. All of this crap for, like, IPsec is so complicated. It just just getting that stuff running. But anyways, so we package all of that in there. Okay, going back to, I think I'm almost through. Who knows? I would take so much time just explaining files. So I'm gonna kind of run through the rest of them. So contract is a more networking thing. Find, oh crap, who is using Find? But I know it used to be, I think CAdvisor was using it. Maybe they're not anymore. I hope that one we can get rid of one day. The shim, this is part of Containerd. CNI, so all of the CNI drivers, we actually package into one multi-call CNI binary. So that's like all the flannel stuff, and there's a bunch of the different binaries needed for, like, host gateway or port map or bridge. There's a bunch of different binaries for CNI. That's all in there in a multi-call binary. So, and then it was Swan and then Containerd itself. So anyways, so that's all the crap that we package inside of K3s. So there's, like, in all of this, like, it's almost like maintaining a full distribution of Kubernetes. I'm not Kubernetes, of Linux, because we have this project in here called K3s root. And so all of this is based off of, like, that whole archive is all based off of this project, K3s root, and K3s root is based on build root. So you can see, how we, basically how we do all this. Here's, like, the busybox config, and there should be, where's the actual build root config? Yeah, here's all the build root configs. And so then we also compile this for, like, AMD 64, AMD ARM 64 ARM, and then there's some support for PPC here. We don't officially support PowerPC, but I know a lot of the IBM folks have gotten K3s running on PowerPC, so they must have upstreamed that one. Okay, ooh, that's a lot just for a binary.
I'll just say, though, this is super interesting that K3s is such a tiny Kubernetes distribution as it is, but already you're looking at which other bits can we strip out that we aren't needed, that these tiny tools are like, yeah, that's bloat, I don't need that, we're going to get rid of that.
Yeah. I mean, it's amazing what we can. So it's like when you look at the actual bin, it's like it's grown a little bit over time, but we're floating at about 55 megabytes. But honestly, on disk, once it's decompressed, it's 147 megabytes, and then it downloads a couple more images into varlib. Varlib. We'll just look at the whole varlib rancher. Yeah, 600 megabytes. So it's like, it's a tiny little package, but it kind of explodes out into a bunch of stuff. It's kind of fun. I love these little things. Like, okay, so I'm going to go on and I'm going to talk about the agent tunneling. And this is going to be, let's see. This is going to be super. Okay, so right now I have Okay, so I already have K3s running here. So what I'm going to do is I just need the IP address of this machine. Use the private network. Okay, I'm going to go over to another node here. Just make sure I can talk to that one. Okay, and I'm going to join this one to the other node. So I'm going to have a master, like the control plane node, and a worker node. You can pass a bunch of arguments and stuff to the shell script to configure. I highly recommend you go with the config file approach to configure and manage K3s these days. So this is covered all in our docs and everything. But there's just a file in here as config YAML, and the format of this file exactly matches the parameters. Like on the command line, if I was to type like K3s server -- server foo, it's going to be exactly the same. Like the parameter here is going to be, oh wait, server was a bad example because I just repeated that twice. But so the parameter in here is going to be token, foo, like that. So it's like there's an exact one-to-one correlation between the CLI arguments and what goes in the config file. But for me to join a node, I just need the node token here. Let me copy this over. Okay, so I'm going to set up this. So I've got this config file in place. I'll show this again just so you see what I did here. So it's an etc rancher K3s config YAML. I just put the token in server. I did the server wrong. Hold on, let me edit that. The server needs to be the HTTPS, the URL, not just the IP. 6443. Okay. All right. So that's the token in server. And now I'll install K3s, just using the shell script. And so the one little catch is you do this, you say -s. What this -s does is it means tack on arguments to the install script. There's also env vars and a bunch of other things. Like if you look at the shell script itself, this is all documented in the shell script. Like all the parameters and everything. So if you ever want to know how to use the install script, just download it and read it. It tells you all the magical arguments to it. But here I'm just going to do -s agent. So this is going to install it as an agent, and you'll use that config. So now if I go back over to the kubectl get node -- watch. Okay, so hopefully, usually it's about less than like about 15. Yeah, okay, so that's coming in. It's usually about 15 seconds to like download and join a node and for it to become ready. So this node has come in. Let's just give it a couple seconds. Okay, so it's ready. All right, so that's how fast you can install it and add an additional node. Okay, so what I want to talk about is the agent tunneling. So this is like a major so in order for K3s to work, the networking, you have to have a bidirectional communication from the nodes to the control plane. And so you need, that means the control plane needs to be able to make a connection directly to the kubelet, and the kubelets need to make a connection to the control plane. This is a pain in the butt to set up in a lot of environments, especially when you're doing like weird heterogeneous setups. So because you have to worry about firewalling, like it's always easier to make an outbound connection than to allow inbound connections. So we run into issues from Rancher, as we've supported Kubernetes over the years, just getting a lot of the networking and DNS and host name and all this stuff set up properly causes a lot of people problems in getting Kubernetes. So we wanted to work around all these things. So what we do is we actually have this tunnel, this reverse tunnel running from the nodes to the control plane. And so the nodes only make an outbound connection to the control plane, and then the control plane can use this reverse tunnel to talk back to the nodes. This is all done through this one project in Rancher. It's called Remote Dialer. Super low level. I can't imagine anyone be able to understand and use this project. This is actually used internally also in Alex Ellis's Inlets project. He uses remote dialer for some of his stuff there. And we've used this extensively also in Rancher. It's a pretty battle tested thing or whatever, but it's not a pretty piece of code. I wrote a lot of this code, and I'll tell you, like, the APIs are just terrible, but anyways, it seems to function. So so I want to demonstrate like how this is working here. So if I look at what are all of the listening TCP connections on this host, so you can see here, okay, the majority of the connections, like these are a bunch of random things. The majority of the connections, like a lot of these have to do with what's running on the host, kube proxy, kubelet, and whatnot. we really wanted everything to be listening on localhost. We didn't want anything exposed publicly. Unfortunately, Kubernetes kind of requires that the kubelet has to listen, has to open up this port to 10.250. So this port is open, but I will ensure, like I will say, it is completely authenticated and secure. I can show you that here. When we run the kubelet, the things that you want to look for is anonymous auth is false, authentication is webhook, authorization is webhook. And so it's running on TLS and it's fully authorized. So that port is secure. But we ideally would like that to be listening on localhost, but for metrics, it has to be running. But so what I want to show you is, so if I go into this other host here, let me get the address of this one. IP address, IP address show. Okay. Okay. If I curl this 10.250, right? Okay. So I'm just proving right now, like that port is in fact open, but it's giving me a 404. If I actually tried to go to something, it will give me, it'll give you an unauthorized, but it is secure. So, but what I'm trying to demonstrate here is, okay, so here from the node, because I'm on the same network, there's no firewalling issues. I can just directly hit the kubelet on the worker node. So this tab here is the worker node. This tab here is the control plane. But if I go and I block, if I block inbound to that, so let's imagine I was running through some firewall, like let's do some IP tables magic. This will block all new connections to 2550 that are not from localhost, and then we'll drop that. Okay, cool, that worked. Okay, so now if I run this over here, we should see, yeah, okay, so it's blocked off. I cannot connect to that port anymore, right? But in order to do something like a kubectl exec, I have to be able to talk to that port. So you can see here, let me find a pod. Oops, -o wide. Okay, so this pod here is running on that machine. So if I do kubectl exec, namespace kube system, this guy. Okay, boom. Okay, so I got into this. So normally in Kubernetes, the way this works is the control plane will make an outbound connection to the kubelet to establish a tunnel to pipe through the TTY data or whatever. And here I've completely firewalled off that node, but I can still get access to it. And you can see the way that is working is 1025 right here. It's this connection that just opened up. So you can see we are communicating through localhost. So it's all going through this reverse tunnel. Okay, so we set up all this reverse tunnel. So this makes like, so this helps with logs and exec. Those will automatically, like those will be, they work through this or whatever. So it's like one of the things that people will ask is like, why don't we use kubeadm? We don't, because we don't use internally, like we don't provision, like what kubeadm is, it's called basically, it's kind of been classified now as a Kubernetes bootstrapper. Is like, in order to start Kubernetes, you need certificates, you need arguments. That's largely it. It's like to start Kubernetes, you need a bunch of certificates and you need all the proper arguments to the binaries. And kubeadm is a bootstrapper that will generate certificates and generate the arguments and kind of bootstrap Kubernetes. K3s does not use that. And the reason why we don't use it is not that like I have any issue with kubeadm. It's that like we want to bootstrap a heck of a lot more stuff than what kubeadm does. Like I would like to be able to wrap or leverage a lot of the kubeadm stuff, and we're trying to do that right now. We have some efforts going on to figure out how we can leverage more of kubeadm. But fundamentally, what we do with K3s is significantly more. So this is one of those examples. Is like, well, we're also running like these reverse tunnels and all of this stuff that kind of sits below Kubernetes. And so that's why we have like our kind of our own technology or mechanism on how to bring up the whole system to accomplish things like that, like this. Because so, okay, so let me go through. I mean, how long? So I'm 40 minutes in. I had no idea I was going to talk this much.
As far as I'm concerned, you can continue this all night. This is super interesting. So
yes, I mean, if you don't mind, I can go easily for like another hour. You know, if people get bored, I don't know. So,
I'm on board. I'm learning lots. So yeah, keep going.
Okay. So this is how we're doing the tunneling or whatever. So let me but I will say, like, the one downside, because I said Kubernetes does require that port be open, and since I blocked off that port, where you'll see that manifested is if I say, oh wait, no, oh, here, this is the reason why this is still working is I never restarted because I just blocked new TCP connections. I didn't block established. So if I actually restart the agent here, you'll see then. Yeah, the number of connections is down here. And now if I look at this, within probably about 15 seconds, I think, you'll see that the stats for this node will drop offline. That's why we have to, unfortunately, open up that port still. Like, I can't just listen on 127 because of the way that people grab metrics, like from Prometheus and stuff like that. They're assuming you can hit that port publicly. Eventually, once your metric server, there it goes. Okay, yeah. So you see, it drops it because it can't connect to it anymore. So if I go here and drop, just delete that rule. So that was the rule that, you know, within 15 seconds to a minute, this will come back up. Okay, so now I want to talk. So I talk about the tunneling. I want to talk also. I want to go into talk about some of the client side load balancing and what we're doing. But in order to do that, I first need to set up an HA setup. So let me we'll talk through some of the etcd management stuff. So what I'm going to do is I'm going to set up a 3-node highly available cluster of K3s. The way this works is it is going to run embedded etcd. This, you know, I'll demo this. This should be the easiest 3-node Kubernetes fully HA setup you've ever seen. This should be pretty simple. But in order to do this, I'm going to kind of clear the state of everything first. So again, like I'm going to do here, I'm going to shut down K3s agent. Let me just say K3s kill all, and I'm going to wipe out so I'm going to just kind of start with a new cluster here. So I'm going to wipe out manager K3s and do basically the same thing on the first node here. I think I can just run K3s kill all. That should shut it down too. Then wipe out, oops, I'm in that directory. Then wipe out var lib rancher. Okay, so I should be back into a clean state. So in order to set up a 3-node cluster, the one tricky thing, and this is actually, it's kind of hard to automate. Like one day we'll probably hopefully find an easier way to automate this, but there's like, in order to bring up a 3-node cluster, you first have to initialize it on one node, and then you join the other nodes. So to initialize it, what we're going to do is we're just going to go into, here, I'll show you from the help first. K3s server help. Okay, so it's this one, this parameter here, this cluster init. I don't know, we need to drop those. This is not experimental in any way. This is like well supported at this point. Yeah, these shouldn't be marked as experimental. Cluster reset. Okay, sorry, not reset. Reset. That's when things go really bad. I can show you reset if you want when we're done. But so cluster init. So what we're doing is on this node, we're going to run the init. So again, I like to use the config file. So edit this config file, and we're just going to say cluster init. Since this is a Boolean parameter, like what I want to type on the command line is that, like, just we then, the way we express it in the config is as a Boolean. So we just say cluster init true. Okay. So then now when I bring up system start K3s, so we're going to start up K3s just, you know, through systemd here. the reason why this just like the reason why like when you type start it waits a little bit is we have systemd integration into K3s where we wait until kubectl is fully available before we say the unit is started. So basically we're guaranteeing that like right after the K3s start, as long as that exits correctly, you can immediately start running kubectl. So this makes automating things a lot nicer because you don't have to run some other type of thing where you're waiting for kubectl. But it doesn't guarantee that Kubernetes is fully initialized. We're just making sure that kubectl works. But things are still usually booting up. Like if you say like get all like this, yeah, like say for example, this one's not ready yet. But whatever, that was just 9 seconds ago. So this will become ready probably by 15 seconds usually. Yeah. Okay.
Aaron, a couple of quick questions before you move into further detail. Alejandro has asked if it's possible to generate a token before installing all of the nodes. So rather than have to wait for the master to come up with and generate its own token, can we inject the token into all nodes at the same time and bring everything up at the same time?
Yes, you can. So when you run server help here, what you can do is just basically you just specify the token yourself. So if you don't specify the token, so where's the parameter? Not agent token. Towards the top. Token here. Okay. Token or token file. So this is a shared secret used to join servers. So you can just specify some random value. Okay.
There's no minimum specification or?
What was that?
There's no minimum specification or format that has to be?
No, it's a string of characters. We don't really care. Don't put spaces in there, or don't put white space. But just some characters. Yeah, so it doesn't matter. But I will say this is something we're trying to improve, is that right now if you grab this one, you can see this has a bunch of crap in it. It's like formatted a certain way because this token is actually more secure. It does more validation of some of the cryptography crap than if you put in your own token. And we're trying to improve that so that people can specify their own token, but it can still be as secure as these tokens. This has to do with like when we start up K3s, we have to generate a series of CA certificates. If you know how to generate the CA certificates, this value here is right after the K10 is actually a hash of the CA certificate. And so, yeah, so we're actually hashing the CA certificate. So we're doing like a trust, trying to trust the TLS up front. So this node token approach is more secure than doing a shared secret.
Okay.
But the shared secret works too.
Okay. Thank you for that. We've got a few questions.
Sure. Go for
Everyone's loving this. So next one, what does cluster init actually do?
Right. Okay. So cluster init. So this is because by default, because K3s is very heavily like people use it a lot in a single node setup. That's probably the most common use case for K3s is single nodes, or like a single node cluster. So cluster init tells it to don't use the internal SQLite implementation. Instead, use the embedded etcd, and then it initializes the etcd database because etcd is a raft-based consensus system, and so you effectively have to initialize it in one place, and then everyone then joins in. I mean, there's the ways kind of actually to do that across a bunch of them, but this initializes etcd effectively and puts it into the mode of we're going to be running etcd all the time.
Okay. Can I sort of tag along on that question where Igor has asked, is it possible to migrate from a standalone K3s node to an HA K3s cluster? No.
And this is like a big gap right now. I mean, I was literally before this call on top, like talking to the engineering manager for K3s at SUSE here of like, we need to get this because so unfortunately there is no, if you have a single node, you cannot move to etcd right now. Yeah, It's unfortunately like there's not. So like we're trying to just, so before when we used to, before we did etcd, we had DQ Lite and it worked with DQ Lite. It was very simple. We could move from, because DQ Lite was also a SQLite based thing. So we moved from, kind of like one SQLite implementation to another SQLite. And so it was very easy to upgrade. But etcd requires us to do a little bit more manipulation of the data to move from one style to another. So unfortunately it's not there. It really bugs me. And so I'm glad you brought that up, and I really hope we fix that soon.
Okay. And the final question we've currently got open, for what functionality is K3s using IP tables?
Oh, well, I mean, that's Kubernetes, like, and crazy. Kubernetes is its own little mini service mesh of like Kubernetes does, moving all this data, like private networking and port forwarding and all of this stuff. And so the kube proxy is the one that uses IP tables. So we don't directly, like K3s in terms of like the K3s specific code does not interact with IP tables. It is Kubernetes that uses IP tables, and specifically is the kube proxy, which uses it. If you're like, I hate IP tables and I don't want to use IP tables, then there's other approaches like KubeRouter or Cilium, where you can drop the kube proxy completely. This is getting more advanced territory, where someone could drop that and use non-IP table based stuff. But at the end of the day, Kubernetes has to move around a lot of traffic. It's got to doing a lot of natting and stuff like that.
Perfect. Thank you. That's the end of the questions.
Okay, so let's see. Hopefully we started up, right? Kube, CTL, get node. All right. So at this point, I think I'm grabbing I need the node token. Since I wiped it out, it's now got a new node token. So, so we can see here the roles now is control plane, etcd, and master. Kubernetes, right? Like I'm running, I believe version, this should be 120. I think that's the stable right now. Yeah, 120. So Kubernetes is going through a transition right now where they're deprecating the term master and moving to control plane. So that's why you see three things here, but control plane and master are interchangeable. Eventually the master will be removed and it'll just be called control plane. Okay, so, no, sorry, go back and copy that token. So here now I'm going to oh, you know what? I need to just completely uninstall K3s because I installed it. K3s. Wait, did I uninstall? User local. Oh, I didn't realize that. It's called K3s agent uninstall. Let me just completely remove it because this is no longer going to be an agent. Like K3s runs in two modes. It's like a server or an agent. So for a highly available HA cluster, I need 3 servers. And then you can have as many agents, which are the worker nodes. So in this situation, so I'm going to set up 3 servers. So that's why I'm just completely uninstalled that. So if I go here, K3s, oh yeah, and the uninstall will wipe out the directory. Rancher, K3s. So I'm just creating this directory, and then we're going to edit Rancher K3s config YAML. And here we want to put the token. And again, we want to put the server URL, which let me go back here and get the IP. It's going to be this private one, 6443. Okay. So now that I have that config in place, let me install K3s again. And so I'm just doing the default installation because the config's already here. And then while that's installing, that should take, maybe 30 seconds or something. I can watch the logs here of K3s. Oh yeah, it looks like it's already. So you'll start seeing like, some messages here from Raft. Okay. Yeah. Okay. So this is the one I want to show you here. So the way we're managing etcd is super cool. I'm super so I this is all the team has been working very hard on the etcd integration for quite a while, trying to make this rock solid and simple. And so the way it works is when you join a new server and we put it into learner mode. And what learner mode is it looks at the current state of the etcd cluster, like the Raft log, and it will replicate over the entire log. It's learning the whole state. So while it's learning, that does not impact the etcd's ability to change state. Like before we had learner mode, that would actually cause issues of blocking writes, I believe. But now with learner mode, it doesn't matter like how much state is in etcd. We start the nodes in a learner mode. Once they learn the whole state and they're like now in synced, we then flip it over to a a real participating member of the cluster. So now at this point, if I go back here, say kubectl get node, yeah, so you can see we have two running. Okay, but we only have two, like, which is bad in a quorum based system. This is like 2 is actually worse than 1, whereas 3 is good. So this is like, you don't want to have 2 because that. So anyway, so we'll now set up the third one. So in order to set up the third one here, we just need to replicate the configuration. K3. Oh, no, why did I do that one? On the config, not that. Okay, so we're just going to replicate over this configuration here. So now I'm on a third node, same deal. We're going to create this directory, branchery, K3s, then we're going to edit, oops, type brancher, right? Okay, and then, man, trying to rush. Okay, so we're going to put this in place. So we put this same file in place. Okay, now, again, K3s.
Someone said learner mode sounds confusing. I don't know if this is a correct way of explaining it, but maybe it might sort of help it in different terms. It's like MySQL replication where it replays a transaction log to try and get you back to the same state.
Right. Because it's like,
is that sort of a correct analogy?
That is effectively a correct analogy of like, it's like doing the bin log streaming or replication because the way Raft works is like, it's just a log of mutations, of changes, of like change. So it's like just one, like you're just kind of tailing something. So the problem is when you add a new one in, what we need to do is we just need to tail the end of the log, but I can't tail the end of the log until I have the beginning of the log. So when you do the learner mode, it's basically it's piping over the entire stream of the entire log until it learns the entire thing before it starts participating. Because if it tries to participate before learning it, it effectively cannot confirm a write until it's learned the entire thing. And they'll effectively halt the whole cluster and then chaos ensues. Okay.
Fantastic. We've got a few more questions as you asked for them to be during the time.
Go for it. Yeah.
Okay. Is there a difference between the kill all and the kill agent script, or is it just literally naming?
They're just named different. I don't know why we did that, to be honest. It would be better if it's just all K3s. Yeah, because so I think, well, no, that's probably not true. I wonder if there's any difference. I don't know, actually, because the agent script was that was introduced a little later, and I don't have hands-on knowledge of it. Yeah, sorry, actually, I don't really know.
Okay. The next two questions are kind of related. So one person asked if they specify cluster init when initializing the installation at first, it then won't use SQLite, so then later on you can go to multi-master.
Yeah.
Correct? And another user has asked, is there a negative performance implication for running a single node?
Yes, there is. Yeah,
right.
And so we've tried to document this a little bit. So there is a downside of, I think it's Rancher docs. Let me see if I can find it. There is a downside of like etcd does require more resources. That's why we use SQLite for single nodes setups. So there's somewhere in here. I don't know. I don't know where it is. It's somewhere in the docs. We actually embedded with embedded DB. Crap, I don't know where it is. We've documented this somewhere. Maybe someone who knows can point it out or something. Is like there's somewhere where we talk. There's a little bit more memory. It takes a little bit more memory than SQLite. But then the more important one is it highly increases the number of IOPS. Like etcd is doing a lot of F syncs to the disk, and it's kind of constantly doing it. So what you'll see is like if you want to run this on a Raspberry Pi, etcd will just like kill an SD card. So SQLite is significantly, it's like works much better. It's like much lighter weight on the disk. So if you do care about more lighter weight, lower resources and whatnot, then that's why you're going to want to stick with SQLite. And that's why SQLite is still the default, because etcd does add, this overhead.
Okay. 2 more questions. Can we set up and bring down a highly available cluster in one go instead of configuring each node?
Well, that's where it gets like a little tricky to configure, because like as I said, like you have to have like init one and then join the others. And so the way people typically do this is it's kind of like a bootstrapping procedure of like let's say I was doing this in like Terraform or something like that in the cloud. What you would typically do is kind of like create a cluster init ASG that has one, or like just a VM. You don't have to do an ASG, but like you just have one VM that's the init node, and then you create like 3 nodes that will join the init node. So you have a 4-node cluster, and then you delete the init node. So it's like it's kind of crummy. Like it's a super hard problem to bootstrap, because in order to bootstrap, the bringing up a clustered system requires effectively another consensus. And so some things like console does a good job of this, because like they kind of already have a lot more interaction with the internal state or whatever. So we're trying to improve this, but like right now it's kind of a little tricky to automate bringing it all up.
Okay.
But there's a lot of Google around. There's a lot of people have tried different scripts and automation. We have Terraform scripts for it too, from Rancher. I don't know where those are off the top of my head, but they're out there and stuff.
Okay.
Or just use like Civo Cloud.
Absolutely, make it easy. Can I join a virtual kubelet worker node to K3s cluster, or is it in the roadmap?
Yeah, it should work. Yeah, you shouldn't have any problems. Oh, actually, let me point out, this is a totally random enough point. There's this project called System K, and this is no, actually do want to search for System K. Let's see if I can find it, because it just moved. It's now nope. Gosh darn it! It just moved, because now it's. Where is it? Yeah. Yeah, this one. Okay, archived. There you go. Now it's because this has moved to the virtual kubelets. Okay, so this is a super cool project. Even though like I can't stand systemd myself, but it's like such a cool use of technology. Of like what this project is doing is you run a K3s control plane, and then you create virtual kubelets that interact with systemd that are actually creating systemd units and installing like Debian packages. And so you're managing systemd as a virtual kubelet through Kubernetes. It's like, I don't know if there's anything practical use case to this, but I just thought it was an amazing use of technology. And
we talk about turtles all the way down, right?
Yeah. I mean, whatever. I mean, it's like I love this stuff. But it's I tell you, it's like always the most ridiculous ideas that like it was like, oh, it was a hack, and then we did it enough, and we're like, nope, now that's best practice, and it's good. So anyways, so yes, virtual kubelets do work with K3s, and it should work. And so this is like a decent example of this project. If you want to see how to join a virtual kubelet to it, because this one acts as a virtual kubelet. I think this is like kind of the catch. You just need to figure out like what the kubeconfig is.
Fantastic.
But you can look at the internal files and stuff in K3s and find those.
Cool.
Okay.
The final open question: why have you moved away from Dequolite? It looked like it was the way to go for clustered Raspberry Pis.
So Dequolite, the problem there is like these graph systems really suck to support. Like the major, like at Rancher we would supporting Kubernetes. I don't know, 4 or 5 years, something like that. However long Kubernetes kind of been around, we've been supporting it. And the number one thing of supporting people running Kubernetes is etcd. And it's not that etcd itself is a piece of crap, right? it's that running persistent systems, and especially clustered consensus-based systems, is quite hard. So when it came down to it, it's like, it just didn't make sense to us that to try to stabilize and maintain and support DQ Lite, because it has a very small community. You know, as a couple developers, or I mean, really one main guy created it, brilliant guy, created it, and it's supported by Canonical within micro K8s, but it's nothing compared to the community that it exists around etcd. And so even though etcd has been around, you know, for years now, it's very stable. It is still enhancing and adding new features, and we are taking advantage of new features and things that are being added in there that are really helping with like disaster recovery and operational scenarios and all this stuff or whatever. So it's like, when we looked at it, it's like DQ Lite was lighter weight. etcd added more, you know, it was a little heavier weight, but the pros of the community and the stability, all that stuff outweighed. And so we ended up dropping DQ Lite. But we had no specific, like, there was no real problem with DQ Lite in that, you know, it's not that it wasn't, well, it was kind of broke in the implementation we did, but that had more to do with what we did, not DQ Lite itself. So like that technology and that stuff is fine. It just has more to do with the community and supporting it and what we really felt comfortable with.
Cool.
Okay,
back to you.
All right, so at this point we should have a 3-node cluster. Yeah, okay, so we have a 3-node cluster. So now the whole point is, so I talked a little bit about the etcd management. So again, this is all built into K3s, and also kind of shows of like why what we're doing is significantly more than kubeadm, of like the style of what K3s is. Like K3s actually runs as like a daemon on the host before Kubernetes. It kind of supervises Kubernetes itself. And so we can do things like this, like the etcd management, the tunneling, the whatever. There's a lot of logic in there about how we're transferring around keys, because in order to join a master node, I need the CA certificates. Like right now, if you do kubeadm, that's like, well, copy them somehow yourself. But like we're managing that all for you, and we're trying to do that in the best secure way that we know of. Okay, so let me go. So in order to join an agent now, because I have a 3-node highly available cluster, but now I want to join a worker node. And the reason for this is I want to talk about some of the client load balancing stuff that we're doing. Okay, config. So in here, I'm just going to put the exact same configuration. Random thing, there is, for highly available clusters, there is actually something like what we're using is the node token or server token. There is something called a agent token that does exist too, that you can specify a token just for agents, so that just agents can join the control plane, and they don't have the ability to become a server and participate in the server state. And so this is a security thing where, yeah, like because as soon as somebody joins as a server, they have the whole knowledge of the cluster, which includes all the secrets. So I'm joining as an agent, using the agent token, then you only have the knowledge of yourself effectively. So that's another, like that's more like for advanced setups that really care about security. There is something called the agent token. Okay, so here we put that in place. We're going to install git K3s IO. Okay, but we're going to install it as an agent. So I'm going to do the -s agent. These are like, just FYI, these are like, as I said, like with the install script, there's like a million different ways with parameters and whatnot. The only two I know off the top of my head is the default one and the -s agent. And then I do everything else through the config file. Okay. Okay. So you'll notice here, my voice just cracked. Let me point out something. I'm on an agent, which is just a worker node. There is no kubectl on a worker node. It has no access to all of Kubernetes. It only has access to what the node is supposed to know. You know, so there's specific like node RBAC and stuff like that that limits the scope of what it can know. So just from like a debugging perspective and whatnot, I just want to point that out. It's like, if you're on a worker only node, you can't talk to Kubernetes. You don't have full access to it. Okay, so it came up and you can see the roles is none. None means it's not a, it's not a control plane. The etcd role, I think, is actually not a, I think it's a role we made up. I don't think that's actually a standard role in Kubernetes. The only standard role that I know of is control plane, because then the lack of control plane means it's a worker node. Okay, so now all this, the whole point of setting up this whole thing is I want to talk about the client-side load balancing. So if any, savvy users thought during this whole thing is when I set up this config, everything is pointing to this one node. That's the very first node. So then the question becomes of like, well, what the heck happens when I shut down this node, right? So now I've shut down K3s there. So all of these, they're pointed, when I set it up, I pointed it to that one node. So then the problem is, well, crap, I lost that one node. Does my entire cluster go down like when I try to restart or something like that? And the answer is no. And the reason why is once it joins in, we start watching all of the control plane nodes. And if you go internally in here, varlib rancher K3s, I think it's agent. No, I think it's etcd. Okay, so what happens is once the agent joins, and the same logic effectively applies to the server nodes too, but once the agent joins, it starts watching what are all the master nodes. And it starts monitoring the addresses. Actually, shoot, let me bring this one back up just so you can see, because it already saw that the node went away. We'll just do this. We'll just watch. Oh, sorry, back. Okay, so what it starts doing is it starts watching, like it has the server URL. That's the initial URL that we use to join. That's kind of used as a reference point of like a fallback of like if one of these server addresses don't work. But we're constantly watching the servers and seeing which ones are available. We just get this from Kubernetes itself. So when Kubernetes says like, well, the node is not ready, then we'll pull it out of the list. But if we see ready control plane nodes, then we keep it in this list. Now if I look at the agent when it starts up, let's see, kubelet. No. Maybe it's from top. Might be better. Okay. Yeah. Okay. So here is the really long. This is like kind of internally all the parameters that we're passing to the kubelet. Now the one that we want to look at here is the kube config. It's this parameter right here. So what the kube config parameter to the kubelet is this is the client configuration of how the kubelet is going to talk to the control plane. So if I go and I look at this file, you will notice that it is talking to this random port. So when K3s agent comes up, we actually bind the random port, and then we run a TCP load balancer. It's implemented, it used to be Google TCP proxy, which is now, crap. So, yeah, it was this project here, which this project has now moved over to internet.af. But anyway, so it's based off of, oh yeah, it's already redirect. So it's based off of this Go project internally. So we're running this TCP proxy. So, so this makes it so that in order to run a highly available setup, I do not need an internal load balancer. Because typically in a normal Kubernetes setup, if you have 3 control plane nodes, you put those all behind a load balancer, and then all the worker nodes join that, or they point to the load balancer. This removes the need to have a load balancer because we're just dynamically learning the state and load balancing or whatever. So now, we can see that, as I kind of demonstrated before, when I stop this, this guy here will eventually learn its state. Like we'll learn the state. Let me see if I can actually do this. I wonder if we'll see. Right. Okay. Right here. So you can see it was like when I brought it down there, it started getting a bunch of connection errors. And then it updated, it stopped the tunnel. I don't know, whatever. Like you can see, like it's doing a bunch of crap where it's like basically updating the load balancer state. Yeah, so it stopped that one tunnel. So I think that means, yeah, because it lost or whatever. So we're dynamically watching all that. Okay. All right. So that's kind of how all the client side load balancing for the workers or the agents work.
Very cool.
Okay. What was the other things that?
We've just had a question come in. Are we bound to use IP addresses, or does K3s support DNS host names or multicast DNS?
I can't really comment on the multicast DNS. I don't know if that one, but like we are not bound to IP addresses. Thinking. Is there any issue with? Okay, yeah. So I'm trying to think like what are any. So basically, what it comes down to is like by default we do the IP addresses, but if you want to use host names, the only thing I think really matters is when you launch the server. There is a parameter in here. Blah 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 blah. TLS sans. Okay, yeah. If you're going to run your servers nodes behind a host name and you want the agents to join the host name, you need to basically tell us what the host name is so that when we generate the certificates, we put that in the certificate as a subject alternative name. So that's the only thing you need to know for that. I will call out one thing though, is that because we're learning these IPs and we're talking to them, is like if you do put a load balancer in front of the server, the server control plane, we use the load balancer to kind of initially talk to Kubernetes, and then we learn the node IPs, and then we talk to the node IPs. We will then start bypassing the load balancer. And this is because of the client-side load balancing logic and whatnot, is like we don't depend on, but there is, if you really care and you're like, I don't want it to do that, when you run the agents, there is a flag for this. Where is it? I swear there's a flag. Maybe it's on the server. I swear there's a way to disable the load balancers. I'm not seeing it, but I'm pretty darn sure there's a way to disable the client side load balancing behavior. Like in general, every feature that we do in K3s is like we try to make people's life easier, but we know there's always corner cases and whatever, and so there's always some like way to turn it off. But why am I not seeing it? Okay. Protect you. I don't see it, but I swear there's some way to do it. Okay, I don't know. I think there's a way to do it. Hopefully there is. But that's just some kind of advanced things about what's going on. Okay, so let's see. Going back to, so talked about kind of the binary, the agent tunnel, etcd. That okay. So I want to get into some of the fun little hacks we do around node DNS. So one of the things about Kubernetes is the default behavior of Kubernetes. Oops. Oh, shoot. I stopped it here. Let me start that back up. The default behavior of Kubernetes is that the nodes are valid DNS names. Okay. So here, well, like I said, this node over here, 2529. So Kubernetes really wants these to be valid DNS names. And there's assumptions in other software and whatnot that you can reference the node by the DNS name, which is just not like in this environment where I set this up. This is just in some random cloud provider somewhere. These host names are not like, I can't, let me see. Yeah, I can't ping that. Okay. So that's going to break a bunch of things in Kubernetes. So we do a couple things to make it so that this is not a hard requirement. One is we change the way that Kubernetes, this is just a parameter. when we start up. Let me see if I can. Oops. One is there's I don't know if I'll be able to find it. There's a parameter that we specify. Node restriction. I can't find it. Basically, you can tell Kubernetes how to treat the if you should be referencing the nodes by the internal address, the external address, or a host name. And we default it to like first try, I think, the internal address or something like that. So one is we kind of change the behavior of how that works. That's not like a code change. It's just really just a configuration change. But the second thing we do is we actually make the internal DNS know about the host names. So if I, like, as I just showed you here, like, okay, so this host name does not resolve. But if I go kubectl run image alpine, okay, if everything is right, I should, yes, okay, but I can ping that here. So we automatically, through CoreDNS, we automatically set up host names for all of the nodes. And the way that is done, I believe, if I can remember how this works, it's config maps here, is there, I believe it's this one. Where's the data? Oh yeah, here it is up here. Okay, yeah. So is that we are constantly watching like the state of the cluster, and we are updating this field here, the node hosts, which effectively writes this file node hosts into the CoreDNS pods, and it means like it will. CoreDNS will reference this file as like a host name for all these things. So as you're adding new nodes, we're automatically managing the DNS internally of CoreDNS and adding these things in. So this was we really needed this to work internally for metrics stuff that are assuming you can talk to kubelets and nodes and stuff like that. So that just kind of all seamlessly works. So we do that, and then plus all the TLS certificates we set, we also make sure that they have these in the SAN, the subject alternative names. Okay, so that was a little bit about CoreDNS stuff. So I'm going to skip through kind of this. We'll see how we are on time. These are actually not super detailed. I really want to go over the patches so people understand everything that is changed in. So since K3s is now a CNCF project, we have moved K3s over to its own org in GitHub, and we're going through the process of kind of detaching K3s from, like the Rancher trademark and brand or whatever. So anyway, so everything's moving over to, K3s. And so if you want to look at the packages, like what we do to Kubernetes, the patches and everything, it is in K3s IO Kubernetes. So this is just, it's a GitHub fork of whatever. And then the easiest way is to just look at tags. And so our tags always have K3s in them. And so you can see like this is the latest version of Kubernetes. This is the tag of, the latest one we have. So if you just go and you look at the commits, our commits are always on top. So if you go back here, right here, this is going to be where it starts of this commit should refer to the upstream tag. So if I looked at the, we can see if I'm full of crap here. Let's try this. So that's AF46. So the upstream tag should be this one. Yep, not full of crap. AF46. Okay. So just want to point out, it's like, so we start from the upstream tag and then we overlay our patches on top. And so I'm going to go through these like kind of one by one and explain what these patches are. All in all, the changes, it's less than 1,000 lines of code. And they largely have to do with packaging, but you'll see that as we do this. Okay, so the first set of packages, these ones, all these ones that say Akihiro these all have to do with rootless. So as I was saying, like we've been tracking this for a while of adding rootless support to Kubernetes. If that's not obvious when I say rootless, what that means is a non-root user, a standard user, and a standard Linux user, non-privileged, can run Kubernetes. There's a lot of crazy fancy technology to make this work, user namespaces and stuff. But Akihiro is the one who's really been leading this work. Brilliant engineer. I think he's from NTT maybe, but so we just carry these patches, and so this is coming from. You can.
I assume this is driven by security concerns.
What was that?
I assume that's driven by security concerns.
Yeah, it's driven by security concerns, and I'll tell you that we really care about this for like one specific use case, is that we really see K3s as kind of like it's a very good just kind of application server platform. Like we really think like we're seeing that like more and more like vendors are building their software on top of Kubernetes, and they want to package their software with Kubernetes and then distribute that like to on-premise or something as kind of like clustered appliances to a certain degree. And for something that's more oriented towards like it's just like application, it's not super system level type stuff, they don't need all the additional privileges. And so we really want to be able to run that fully rootless so that we can pass all those security concerns of IT teams or whatever have all these requirements of security. It's like, well, fine, we're going to put in this application which is built on top of Kubernetes, but we don't require any root, and so they'll pass all the audits and whatnot.
Cool.
Okay, so these like all of this comes from this project here. So again, this is same guy, Akihiro Suda. That it's this Userneti project, and if you go in here, source patches, he maintains this set of patches. So with each new version of Kubernetes, he updates these patches with the new version of Kubernetes. We then resync from this project. Eventually, all these patches will go through. They're kind of like what will go away. They're all, well, that one says not for upstream, but basically everything is in the process of getting fully upstreamed, and we're really getting there. That's just been a long going work. Okay, so let's go back here. So that's this first group of patches. Okay, so this one here, disable cAdvisor cloud info. Okay, so K3s does two major modifications to Kubernetes in general. Is we drop support for in-tree cloud providers and in-tree third-party storage drivers. And the reason why we drop those is it significantly reduces like the binary size, the initial memory footprint of Kubernetes. And for the use cases we're concerned about, it's like, well, first off, a lot of people are running this in a non-cloud setting, but even if you're running it in a cloud setting, everyone is moving to external cloud providers. So, so there's like vSphere, DigitalOcean, AWS, Microsoft, there's external versions of all this. So this is all moving that direction. So what we did is, we're fairly well plugged into upstream Kubernetes and everything. It's like, we already know the direction of where they're heading. And since we don't care about this functionality, we can kind of drop it before upstream can drop it. But it's going to eventually get to the point that we won't even have to carry any patches anymore because upstream already dropped it. So for example, like storage is already pretty much that case. Is like what upstream supports is there's a compile time flag to drop all of the in-tree third-party storage drivers. And so we don't have a patch for that. When we compile, we just put the storage, I can't remember what the tag is, but there's a compile time tag. We just add that and it drops all of those. So this one here, this disable cAdvisor cloud info, this patch is just disabling the cloud integration for cAdvisor, because any cloud integration is going to pull in the AWS SDK, the Azure SDK, the Google SDK. These are massive libraries. Okay, so that's why we're dropping that. Okay, so same thing here. It's the same thing. It's client Go has some built-in authentication mechanisms for cloud providers. So AWS, Azure, whatever, the same. It's going to be the same major three ones. So again, we drop those because we're not using that. here's the drop storage plugins. Let me see. I'll show you what this is doing. Okay. So this one here, there's the reason for, oh, it's because there's two places where this is done. It's Cloud Controller Manager in the kubelet. So I believe the compile time flag that I talked about, I believe like that might only be on the API server side, but not on the kubelet side. So you can see here, like these are the drivers that we drop that we don't support in tree anymore. So this is like CephFS, Fiber Channel, Flocker. I mean, Flocker's a dead project. Git repo, Gluster, Portworx, Quobyte, RBD, Scale.io, Storage OS. So those are the ones that K3s does not support. So if these like specifically want to use these, then K3s might not be your cup of tea.
That actually links to a question we've just received saying, is there a way to implement an in-tree storage driver if they need to use one? So is there a way of bringing one of these back into K3s?
Yeah, so that's CSI. So the reason why these are all being dropped and they're all being eventually dropped upstream too, is that everything is moving to CSI drivers. So for example, K3s, oops, let me go back to K3s IO. I'll show you all the all the components that are included in K3s. They're all in the README here. These are all various packages that things. So one of the things we do provide is a local path provisioner. Oh wait, no, that's not CSI. No, that's BS. Never mind. I was gonna say that's CSI, but we didn't implement that using CSI. But but all the newer storage systems are all CSI. And so everything is kind of moving over to that. But the reason we don't end up with, we haven't had like significant pushback on, because I could see like some people being like, oh, I really want like Ceph, but to be honest, we haven't had like much significant pushback on this. If you do have a problem with it, let us know. Okay. But yeah, those are the two things where it's like where K3s, where like we effectively change the functionality of Kubernetes that might make it so K3s is not going to be fitted for your use case. It is specifically the cloud provider integration and the storage drivers. We don't feel like this is disabling functionality in the fact that like you can still bring in more storage providers through CSI and out of tree cloud providers. Anyways, so going back here. Okay, so this is dropping the storage plugins. I believe that's in the Cloud Controller Manager, and the Cloud Controller Manager, honestly, I thought was gone in V20, but okay. So next patch here, drop the credential providers. So the credential providers is again related to the cloud integration. So there's specific integration into Kubernetes to talk to ECR and GCR, and what's the Azure one? But anyway, so the cloud provider specific repositories, that's what this is. It's dropping that. Okay. This one here, this is like a little thing of like Kubernetes, when it starts up, it will check the hash size of the NF contract table. Basically, it's trying to ensure that like your system's in a scalable state. If you don't set this, it will fail. And so basically we've just moved this from being a failure to we just log an error. The majority of setups when it's running K3s, this is not a concern, setting this hash size, because we're not running, K3s is typically not run in very large scale clusters. But if you do care, it is very easy to scale K3s. We've run K3s to, 5,000 nodes. And massive data sets because of Kind, the storage backend that we use. We've had up to 400 gigabytes of data under management in a K3s node. So yeah, you can actually scale K3s really high. It's really easy to do. Okay. This is a super technical one of like use resolve name port. It was 0. There's like this was kind of hard to explain, but this is where it's like, because we're doing kind of tricks with DNS names and IPs and tunneling and whatnot, there's one weird specific flow that makes it so it makes it so that we they do this thing where they bind a port and then they get the IP from when it was bound, but the IP is not really the IP we want anymore. So the only reason why we haven't upstreamed this one, like, because most of the patches, like if we're like, this should be upstream, then we'll work towards upstreaming it. It's usually either like the patches we carry, we know are very specific to us. It doesn't make sense to go upstream, or we know it's like kind of already in the queue upstream and people are kind of working on it, but you know, they're always doing a kind of a prettier approach that takes more time. Or there's some things that we've done that it's kind of like it should be upstream, but we just don't think we did it in the best way possible. So this is the one of those cases where it's like this, I would really like, we should upstream this patch, but I think there's a different approach on how we can do it. So anyway, so that's why that patch has not been upstreamed. Okay, this one actually, we don't even need this patch anymore. I'll explain the history here. There's a little known fact. There's a varlib kubelet is effectively hard-coded in Kubernetes. You can't get away from running in varlib kubelet. And so the previous versions of K3s, we would put the varlib kubelet data under varlib rancher K3s agent kubelet. I think that's where it went. And so we did that before. And so we have patches to Kubernetes to make that possible, where we could configure this path. Basically, what we found is not only is it hard-coded in Kubernetes itself, it's hard-coded in a lot of software that runs on top of Kubernetes. So it is very hard to get away from putting things into varlib kubelet. And so at some point, like somewhere around like K3s version 1.0, like the very first GA version we did, we switched everything back over to varlib kubelet. So you don't have a choice. It has to go there. Unfortunately, the world hard-coded that path. So that patch actually can be dropped. Here's one where it's just basically, on some ARM systems, people run on these tiny devices that just take forever to boot. Here they had this 10-second timeout where it's like on a regular sane system, this shouldn't be an issue, but on crappy ARM devices, it is. We just increased that timeout. I don't know if we can probably could upstream that one. Okay, so here's one where this comes up on some Raspberry Pis. I don't know if on the most modern version of Raspberry Pi OS, but the CPU set C group was not available. You really do need the CPU set C group for some things or whatever, but for a lot of use cases where people are running K3s, it's like if you don't have like that C group is always available in like most Linux distributions, but like Raspberry Pi did not have it in earlier versions. And so we basically just said, well, it's optional. Because if you specifically don't have that C group and the ability to pin things to CPUs, then you probably don't care about that functionality. So we just made it optional. But that one, yeah, this one is like one where it's like, we can't really upstream it because if we make that up, like maybe it was an additional parameter or something, but this one should go away. This one, it's like, might even be the case already if I look at the latest version of Raspberry Pi OS, because it was specifically, this one was done for Raspberry Pis. Oh, this one is yeah, this one's super, so there's two patches that are related here. It's going to be basically this one. Where is it? I think it's higher up here. Oh, that one. Okay, so we run everything in one process. Like, so that's one major difference. And it's also how we reduce the CPU requirements. Is in a standard Kubernetes setup, you're going to have, like on the control plane, you have the API server, the controller manager, the scheduler. You have those three processes, then plus etcd. So 4 processes, I guess. And then on a worker node, you will have the kubelet and the kube proxy. So on the, what we do is we combine everything into one process, and that has worked fabulously well because like all of the Kubernetes code is very well structured, that it works really well, that we can just basically combine everything into one process and just kind of, instead of calling the binaries, we just call a function. But there's a very specific issue with CSI, with the way that the CSI was written, that they have this CSI manager object that runs in memory, and it kind of needs to know if it's inside the API or inside the controller manager or the kubelet. And so we had to make a bunch of change, like not a significant amount of changes, but some small changes around this to make this work. This one, yeah, I'd probably like to upstream this. We can probably get these things upstreamed, but it doesn't change any functionality. It's just the way the code was initialized, unfortunately. Okay, let's see how many more have we got with these. High deprecated warnings. Oh, okay. So we're hiding a bunch of warnings, and the reason why we're doing this is the kubelet has moved to this new config file format, and it's been there for a while, and they deprecated all of the command line arguments. And so the problem with deprecating all the command line arguments is that a lot of people know and refer to the command line arguments, and so we're getting more mind share towards the config file, but so we have not moved to the config file because it's harder for you, like there's not as much information available out there of like what are all those arguments and how to use them and everything in the config file format. So we've stuck with the arguments for a while because it was easier for users, but like it spits out all these ugly warnings. So we hid those, and we're trying to eventually move to the config file format while not making the kind of the UX of all this kind of suck. I'm also, honestly, I'll be perfectly honest, I don't like the config file because, you know, everything else in Kubernetes is all arguments. I don't know why the kubelet has to be a config file. So to deprecate the arguments and only support the config, I don't particularly like that, but it is what it is. This thing, the addability to disable hostname proxy check, this is because of the way we're running the tunneling. How the tunneling goes across is we're looking up. We're not assuming the nodes have valid DNS names because they're going over a tunnel, and so because of that, this one check that they do for security reasons, like it's a good reason to have this check, we disable it, but we know we can disable it because of the way the internal dialer is working, is not going out to the internet. So we disable that. Wow. I deprecate warrant ability to have loop back on cache. Okay. Oh, this one. We found out like when we first deployed on Raspberry Pi, it would like take like, I don't know, over a minute or something to start up on a Raspberry Pi, and it was quite slow. But what we figured out is the reason why it takes so long is it would have to generate a certificate, and the certificate, there's no hardware offload for generating those keys on the Raspberry Pi, at least at that time on the Raspberry Pi 3, I think. So it would take a significantly long amount of time to generate a private key, whereas like on a regular Intel CPU, that takes like less than a second. So this patch in here is basically just making it so we can cache the private key for this one loopback cert that always gets generated on every start. Okay. This patch here is for basically, again, this has to do with Raspberry Pi. This has to do with the Raspberry Pi, and specifically how some of the default networking was set up there. Let me see if it's this one specifically. Oh no, wait. This is. Oh no, this is for I think it's a situation where you don't have networking at all. I think that's what it is. Is like we don't want it to accidentally switch or think the IP is coming from the flannel or the CNI bridge. So this is like a situation where you have a single node and there is no networking, like no outbound networking. So that, you know, to make that work. So this one here, this change for the Kubernetes servers on start for the ports or whatever is has to do with we run like when we run the API server, the public port is 6443, but that public port is actually K3s. It's not the API server. We run the API server actually on a private internal port. And so there's one small change that we made to make that configurable in Kubernetes so that we can run Kubernetes on 6444. So you should be able to see that here. There's 644. Where is it? 6443. That was 6444. Huh, where is it? Yeah, it's right there. Huh, I don't know why that didn't show up on the other one. But anyways, it's right there. So Kubernetes is actually technically listening on 6444, and the 6443 port is K3s itself, which does a lot of the bootstrapping and the etcd management, because it's like we have a lot of stuff that we're trying to run over one port. So we augmented all this behavior, and so that's what that patch is, the ability for us to run Kubernetes on a different port. Oh, okay. This one here, don't check etcd scheme if it's Unix. This has to do with the way Kine works. So Kine is our storage backend that we use to support SQLite. Kine is a separate project. It's an external thing. Like, so if you want to add SQLite, MySQL, DQLite, or Postgres, or there's a PR in here for SQL Server, like Microsoft's, and somebody's working on Oracle too. If you want to run any of those projects or those storage backends for any Kubernetes distribution, you can use Kine, and it adds adds this capability to any Kubernetes distribution. What we do in K3s is we embed Kine inside of K3s, and then we make Kine listen on a Unix socket, and then we pass the Unix socket to Kubernetes. So Kubernetes cannot talk to etcd over a Unix socket, and so we made a change to Kubernetes to make that possible. So that's like a change we could upstream. Like there's so many things that, like, I don't know. It's like we're doing so much, and it's like the effort to upstream these things. It takes a while. Okay. This is actually fixing. Oh wait, did I go too far up? Check fix it. Okay, that I already talked about it before. This is a CSI because we're running multiple processes in the same one. This is like just fixing a little code issue. This is actually an issue. Kine behaves. There was one different behavior in how Kine worked that effectively exposed an issue in the etcd client. So we had to fix that, but it was like the reason why we haven't upstreamed it is because it's like it was effectively a difference in behavior in Kine, and then that exposed that the client wasn't really working right. So we changed Kine and fixed that, but we also fixed the client. But the problem is that you can't reproduce the issue in upstream etcd because it was like, according to the API specifications, we implemented the API specifications, but that's not how etcd actually behaves. So weird. Okay, so okay, I think this is actually really the last major patch, and this one's really interesting. So when we first released K3s, K3s, the very first release that I did, I deleted about 3 million lines of code in Kubernetes. Because I'm just like, any feature I didn't want to use, like I didn't care about myself, I'm just like, I'll just delete this. I just wanted to make the smallest Kubernetes thing I wanted. And so when I first put K3s, this is before it ever became like a real popular project. When I first put it out there, it was like massively hacked up. And like I just removed a crap ton of stuff. And then K3s started getting noticed and picked up, and people are like, hey, I want this piece of functionality. I want this piece of functionality. And there are things that I ripped out. Like they would be like GPU support or something that I just didn't care about at the time. So it became very clear that it's like, no, in order for us to succeed as a project, we really can't disable, they can't be ripping things out of Kubernetes. It has to just be upstream Kubernetes. Eventually, everyone's going to ask for every single feature that's in there. So we spent a lot of time, because the whole reason why I just deleted things was like, I just wanted it to be smaller. So I did kind of like a real, scientific analysis of like, well, what does each one of these things I deleted, what is it adding the overhead? And one thing that popped up, which is like not what you would have ever thought of, is something that added a significant amount of CPU, a significant amount of memory, some CPU on startup, but a significant amount of memory and a significant amount to the binary size was actually how Kubernetes stores the open API internally. So what Kubernetes was doing, what it does upstream, is it takes the open API definition and then generates a bunch of code from it. So there's a bunch of methods and it generates thousands and thousands of methods. So it takes what's effectively like a 1 megabyte JSON document and it turns it into about 40 megabytes of binary. And so that, it made the binary about 40 megabytes larger. And then that's all stored in memory. So then it made the memory footprint much larger. So what this patch is like a clever little hack that we can store the open API as the raw JSON form, and then on startup build what they were doing before with the code generated one. There's probably some way that we can upstream this, but because there's some weird features that the upstream supports in Open API that don't seem to be used in any way, shape, or form, but it caters for these certain features. And so the way that we did it it breaks these features, but they're not used in any way. So it's kind of weird. So anyways, so this small little patch of changing the way you store the Open API schema saves about 40 megabytes of memory, which is pretty crazy. Okay, the rest of the crap, these most of this, I don't think are super important. That's just the tag. That's a vagrant file. This is some things just how we build the system. This is a newer one of master has been renamed to control plane. So I think we had to, yeah, we just had to rename that one thing. This should probably be squashed into another package. Anyways, whew, that was long. Okay. So that's all the patches. And now going through it, I'm like, well, I don't know. I guess it might have seemed like a lot because I talked like a lot, but it's like really this is less than 1,000 lines of code. Each patch, like each one that you go into, they're all like this. It's like just like one line. They're not significantly large patches. Like Kubernetes is millions and millions of lines of code, and we're changing just like a couple tiny little things. And they're pretty much the major things that we're all changing is to make it so that we can package. We're either packaging it in a different way, so we change something, or we're changing, like we're making the system a little more forgiving, so it's nicer to users, and so we're making a certain compromise, saying like, this doesn't really matter for our use case. Okay, I think I'm gonna stop there because I'm going on 2 hours. So
very cool.
I'm done. So I hope that was informative. This is like, I don't get a lot of times when I do these presentations, they're usually more oriented to kind of like 101 stuff. And I don't get into some of the deeper level stuff that I went to. So maybe you'll find this interesting or I just bored you for 2 hours. I don't know. So
no, definitely useful. Considering the unexpected length of it, most people have still stayed around and I've got a couple of pages worth of questions to go through. So
if you're still up for answering some.
Oh yeah. I'll stick around as long as you have questions.
Be
I
careful
think
what you
I'll
say.
keep sharing just in case I need to show anything, but go through them.
Cool. So from Sebastian Gandon, what do you think about the K0s project? K0s.
So K0s, so the thing is, I totally understand why K0s was created, because at Rancher, we have another project called RKE2 that almost exactly aligns with what they're trying to do with K0s. So the idea of K0s is they really kind of copied or mimicked a lot of the style of how we did things, certain choices that we made in K3s, but they want to use more pure upstream components. Not modified and whatnot. And so there's a total good reason for do that, because a lot of enterprise people and whatnot, they're like, it's got to be upstream. It can't be modified. They don't care about user experience or something like that. So I totally understand that. So we have another project, RKE2, that is actually like Rancher's distribution is RKE. Like that's our certified distribution of Kubernetes that we had before we created K3s. And so we've now created RKE2, which is basically based on all the K3s technology of like, it uses all the same bootstrapping and behavior of how we build up everything. But instead of running an embedded modified version of Kubernetes, we run a purely upstream, non-modified version that's run as static pods in the very same style as like kubeadm, and is very industry compatible and whatnot. So anyways, so having said all that, it's like I understand why K0s was created. Interesting project. We'll see how they do. I think it's the one thing I will say. I think it's very odd that K0s does not give any reference to K3s. But that's it.
I don't know if you want to slap a big disclaimer at this point saying all opinions given are Darren Shepherd's only, not anything to do with SUSE, or.
Oh yeah, standard thing. I get in trouble.
Usual disclaimers apply.
Yeah, standard disclaimers apply. This is all my opinion. Blah blah blah. Yeah.
Okay, can I ask a quick technical question that's not going to be controversial?
Sure.
Right, so this is from Piotr, and he asks, like, with flannel routing in K3s, when you want to pass an original IP to the application, it's 1042 whatever. Is there an easy way to pass that to traffic? Because this would allow for IP whitelisting.
I don't have an answer off my. I know this is like just a long-standing issue of basically you're losing the source IP. I think that's basically what it is.
That's how I understood the question.
I don't know what the answer is off the top of my head. I think there's some way to do it, and it's not super easy. But yeah, that's a common thing. No,
is it worth raising the GitHub issue so it can be sort of discussed there and then?
Yeah, you'll find this. So if you go into GitHub issues, this will come up. Like you'll find this. This is nothing new. A lot of people have discussed it, and I just don't know what the solution is off the top of my head. But I know it's a common one that people hit.
Okay, cool.
Yeah, I mean you can definitely because there's we include because we're running traffic under. I didn't get. Oh shoot! I think I had that as a topic, but we have this embedded service load balancer that I was going to talk about, but I didn't, and I don't want to talk now. So we run traffic behind a service load balancer, and the service load balancer is IP tables based, and it will drop the source IP. So there's options of basically not using the service load balancer and running traffic, exposing it directly through like a node port or a host port, or there's different options of reconfiguring it. I just don't know what they are off the top of my head.
No problem. What do you think about Docker Swarm from Soren Hansen?
Yeah. So I love Docker Swarm, to be honest. It just the industry didn't go that way, and so that was kind of like that was Docker Swarm just kind of became a dead end. I mean, it's still a really simple system to run containers on and everything. It's just that the ecosystem and the industry and everything has gone towards Kubernetes, and so it's like if your end goal is like I just want to run a container in a very simple setup, then Swarm actually works quite well. But like if you want to do like all the other crazy things like monitoring and logging and pulling in this third-party thing and whatever, then you start going towards Kubernetes. But when I created K3s, like I actually kind of like tweeted out, I'm like, hey, like would people be interested in like basically like the power of Kubernetes, but the simplicity of Docker Swarm? Is like there was what I did with K3s was heavily inspired by the simplicity of Docker Swarm. And it's at the point that from an administration standpoint, it's just as easy to set up and it's easier to administer because the biggest problem with Swarm was like, it was just this black box that nobody understood. And when it goes south, good luck. K3s is running on Kubernetes. And if something goes south, there's a lot of information out there on how to fix this or whatever. So it's better than Swarm in those perspectives. But I will tell you where it falls, like where it's not better is as an end user of like, I want to deploy a container. It's like, well, you have to know Kubernetes. And that's kind of a steep learning curve for a lot of people.
Okay. Next one from Shahar. What's missing from K3s? What's the next item on your K3s roadmap?
Yeah, so it's like the idea with K3s is like we don't want to expand it extensively. It's like as much if we could do less, we would be happy. So, there's a lot of work in just maintaining this as Kubernetes, because every 3 months there's a new Kubernetes version. Every Kubernetes version comes with some surprise if they change something. So I'm telling you, there's a lot of work just keeping it as it is right now. Enhancements that we're doing is like Right now, there's work with running etcd only nodes. So people who want to separate etcd from the control plane, the security concern for some people, that's being worked on right now. As I mentioned before, we can't do the migration of the, we don't have support for moving, from SQLite to etcd right now. Like that's hopefully should be worked on pretty soon. The one big project that I've been pushing for a while, and I really hope will happen pretty soon here, is adding build support to K3s. This has been a very, one of the issues that was brought up very, very early in K3s is people said, hey, I can basically kind of do everything with K3s. I just can't build, I just can't do Docker build. And so we really want to add the functionality of being able to say basically doing Docker builds on K3s. So you don't have to have a separate system to build images. So this becomes a fairly self-contained development environment for container development. So the big ticket item that I've been really pushing for is trying to get the build. So we had a separate project called K3c, which will most likely not go anywhere, the K3c project, where we experimented around with creating a new container runtime based on containerd. But in that, we also had Docker build support. So we're pulling the build support out into another project. It might still be within K3c right now, but we're effectively kind of going to pull the build portion out into another project to make that into a basically a CLI that can just point to K3s and have, you don't have to do anything except for have K3s and then use the CLI and you'll get Docker build support. And then if that works out well, then we will then kind of upstream that to K3s and it'll become K3s build. So it will take a little bit, but that's the biggest ticket item of what I think is missing from K3s. Other things are farther out on the roadmap is actually handling image distribution and caching. That's a big one for edge deployments.
I'm actually, not that you can see my document, I'm just jumping around in order now because actually there's one from an internal team member at Civo, Dinesh. Any news on IPv6 support for K3s?
Not really. I have no idea what's going on with IPv6 right now. So I couldn't really comment on that. And so, I mean, that was we were waiting for all kind of the upstream stuff. I think at this point is Kubernetes dual stack fully upstreamed. So it's
I thought so.
Yeah, I think it's just been done. Yeah.
Yeah. So the idea was we were kind of waiting for because we didn't see really any reason to support IPv6 only. So we were waiting for the dual stack support to be done upstream. And then it was okay, well, once it's upstream, then we'll figure out. We don't have a lot of people really pushing hard on IPv6. But if it's there upstream and we are somehow breaking that and making it worse or making it so you can't use what's in upstream, then we will definitely address that. We don't want to make Kubernetes worse in any way. But yeah, so I can't really, that's all I can say, I guess, about IPv6.
Okay, just our new platform coming out will have dual IPv4 and IPv6 for IaaS. So
yeah, I'll bring that back to the team and see if they are, kind of what's the status on IPv6.
Yeah, that'd be great. Next one. Apologies to everyone in this list if I mispronounce your name. I'm trying my best. Joao, Joao. Will Rio receive some more love in 2021? It's an amazing tool combined with K3s for getting up and running fast.
I don't know. Yeah, so Rio's been a really interesting project. I really like Rio. I spent a lot of time on Rio. I put a lot of thought into the design of Rio. But the kind of the market around that has. So we're trying to push forward more things kind of in that realm that cater much more towards the developer or the single admin type experience. Somebody who's I just want to run a container and I want a CI/CD flow or whatever. And I think Rio really works great. The problem is there's, if you look at it, it's Rio is not taken off significantly. And I don't necessarily think it's because Rio itself is not good. it's just like, if you look in the space, no project in that space is doing well. There's like, it's really hard right now of like where we were with Kubernetes, is like so many, like the drive of picking up and using Kubernetes is significantly pushed by enterprise. And enterprise over the last couple of years just spent the majority of their time just trying to understand how to deploy and run Kubernetes, not so much onboarding teams, because it was just a significant effort in just running Kubernetes. So now that like running Kubernetes is simple enough, and people have gotten that, now onboarding teams to Kubernetes is becoming a much more bigger problem. And because now it's becoming evident of like, it's really hard for people to use Kubernetes. And so now we're starting to see more demand of like, I need simpler systems that run on top of Kubernetes that are more user oriented. So we have a couple projects. So Rancher, just recently got acquired by SUSE. So we have teams within SUSE and stuff that have kind of worked on these PaaS platforms and stuff like that. And so we are looking at trying to figure out what the strategy is going forward, but I can't make like any commitments about it. It's like, I don't know how much effort is going to put into that. But I will say, like, Rio's not going anywhere. We're not going to like just drop that project, but it's like, we're just not really moving it forward because like, we're not seeing enough demand to kind of to keep contributing a lot to it. But it's something that really bugs me, like, because I just in general, it's like, Kubernetes is so hard to use. It's like that I want something simpler, but yeah, it hasn't always been easy to put simple things out there for Kubernetes.
Absolutely.
Sort of extending the other Rancher product question, Emmerich asks, is there a K3OS replacement anywhere close, or what's happening with K3OS, I guess?
Yeah, well, so so I can't say anything yet about that, but one can assume, being owned by now a Linux company, we will have the ability to produce a Linux OS, and it won't be what's already currently offered. So, we are working on something. I'm very excited about this. There's a lot of things to get in place because, we only officially closed, like Rancher joining SUSE, December 1st was like day one. So it's really only been about 6 weeks or whatever. There's a lot of moving parts, whatever. But I've talked to, like, yeah. So just stay tuned. There is definitely going to be a successor to both K3OS and Rancher OS. I just can't exactly say what that is yet, but I'm really excited about it.
Thank you.
So this follows in nicely from Antanas. When will SUSE appear on Rancher or K3s supported distributions list? Currently, Rancher support matrix lists only CentOS, Red Hat Enterprise Linux, and Ubuntu.
Yep. I think it's like coming out like in the next dot release or something like that. I mean, it already basically works, but it just was not officially supported one. So obviously, we're going to officially support SLES, and even SLED, I think, is in there. I don't know why, but SLES. So yeah, it's coming like in one of these dot, like 2.5 something, 2.56, 2.57, or it'll be there very soon. You can definitely be assured that will happen.
Okay. From Alexandra, is it possible to have flags to disable some K3s components like agent? I think that's pretty much already there, isn't it? You can already disable a bunch of stuff.
Yeah, so like you can disable everything. Again, it's like we add functionality to try and make it easier, but we never want to get in people's way. So there's a whole mass of oops, K3s server. There's this disable flag. Well, these are disabling core Kubernetes components themselves, but it's really this one is like all of these are embedded components. You can turn off all these things. So pretty much every functionality that we've added, you can disable in some way, because people do. For example, like people will do setups where it's like they really just wanted an API server. They really just want like Kube API server. So they run K3s and then just turn off like scheduler, controller manager, cloud controller. Like they turn off almost everything, like the embedded network policy. And then they just get like the API server. So it should all be possible.
Okay, perfect. Do you see K3s bridging the gap between full fat Kubernetes, for want of a better term, and IoT? from Guilherme.
I don't think I quite understand. Bridging the gap between what?
So bringing Kubernetes more to IoT.
Oh, okay. Well, yeah. So, yes, I do. I mean, so this like everything about K3s has just been a complete accident and like somewhat of a fluke. Like none of this was like planned. There was no grand master plan that we knew what we were doing when we created any of this. But like K3s has now basically become like the de facto standard for edge deployments. Kubernetes on the edge is like absolutely blowing up right now. It's super exciting. I honestly thought it was a stupid idea, but like users very much want it. And the reason why they want it is like it doesn't really matter. Like they want the consistency of how you manage and deploy. It's like the cloud gives you all these great ways of deploying software so you can have this fast pipeline of getting things out there. The edge is like very archaic right now, of like a lot of times when people are trying to update software on the edge, they're sending people out to service devices and stuff. And it's like, it's so costly and difficult to push software out to the edge. So Kubernetes, with all of its complexities, like we managed to put all those complexities into this little widget that people can just run. And now it's just opened up this whole realm of like running all of this software on the edge. And the other thing that's happening on the edge is like, before you were just running like simpler, like a kind of like more basic applications, your sensors and things like that. But now people are like wanting to run more complicated stacks like Kafka, you know, they want to be doing AI and stuff on the edge where they have data platforms and stuff like that. And this requires more complicated software. And so they need the capabilities that Kubernetes brings. So what's happening is K3s is absolutely exploding on the edge, but you said IoT. So like Kubernetes is way too fat to run on an IoT device, like a small little sensor or whatever. You're not going to see that. But you see, what you see is K3s running on more of like the edge gateway. So you, wherever you have a whole bunch of sensors, you then typically have another machine, which is a little larger machine which kind of runs as a gateway, you know, to the rest of everything. And so you're running K3s there, and then you're basically plugging in the IoT devices to K3s. And so Microsoft has a great project around this. What is it? I can't remember the name. Where they are. Oh, I think is it Acri? I think it's Acri. No, yep, it's this one. Let me just search for Acri Kubernetes. Yeah, okay, so this is from Microsoft. So Deus Labs, if you don't know, Deus was a company that was acquired by Microsoft, and they're kind of like the bleeding edge Kubernetes development in Microsoft. So Acri, what this is doing is like basically setting it up so that you can run like Kubernetes can discover and manage IoT devices. So effectively and like this whole demo, like if you're sitting this demo, end-to-end demo, like this will show you with K3s, I believe it's in here somewhere. Yeah. So it's like basically you set up K3s on like an edge node, and then you set up this software which will then manage and discover your sensors, because like their use case they're talking about here is, let me see if I can show something here where it's kind of like for every IoT device, it might be a camera. You then want to run like a frame buffer thing, which is then going to pick up the frame buffer, and then you can run AI processing on the images and stuff. And so you have to run corresponding software, which then corresponds to the IoT devices and everything. And so they're building a whole framework for this. So, so you can see Kubernetes will start managing these IoT devices. Then on top of it, the other cool thing that Microsoft is doing in this realm is Crustlet. Okay, Crustlet. And again, so this is again related to K3s of like, because the whole thing is like an IoT device is way too small to be running Kubernetes in real containers. Like I don't want to run this big old fat Go program and all this stuff. So what Crustlet is it's written in Rust. That's why it's called Crustlet, but that actually doesn't explain what it does. It's WASM. So basically WebASM. So this is basically to run WebASM modules like a pod, and you're running them on the IoT device. So you can run this Crustlet, which is a super small Rust binary that runs WASM, and that can run on an IoT device. And then that shows up as a node in Kubernetes. So in this situation, you'd be running like K3s as the control plane, and then you would be running Crustlet on your IoT devices. So yeah, like there's so much going on in the edge space right now. Like I'm super excited about this stuff. Because it like it's not BS to me. that's the thing, is like what I've always thought about like the edge for a while is everyone's always been talking about like, oh, the edge is going to be big and there's all this stuff and IoT, and there's been all this stuff like MQTT and like all these protocols and stuff. And to me, it's all been so academic, like hasn't been grounded in reality of like people really doing this stuff. But like we're getting more closer to like real solutions people can actually deploy. And so K3s is kind of the is like right now kind of like the entry point into that whole edge IoT space. Or, you know, so, yeah.
Cool. Do you have any link or case study about real-time projects using K3s from Rattan?
Oh no, I don't. No. I wish I did. That kind of comes up, but I'm not super like running a K3s on, you know, some real-time OS or something. I don't have any specific information about that. If you find some, I'd love to know it, because it is coming up. Like, so this is like so we're starting to get into situations where like they want to run K3s on things that are more like factories, automation and stuff like that, where they need real-time support.
Cool. With Kind supporting distributed write databases like CockroachDB, do you think it will be a real alternative to etcd and upstream Kubernetes? So switching upstream Kubernetes to Kind.
Yeah, that's a long. Yeah, so the thing is like it's so historically Kubernetes has only supported etcd, and then there were some efforts to add more storage backends, and those efforts in the past, what kind of came out of it was that upstream kind of recommended they didn't really want to pick up any other back end, and they would just basically, you should just implement an etcd shim, like implement the etcd API and then create an implementation behind it. And so that's what Kind is. It's an etcd shim, because that's like what upstream had recommended. So the interesting thing is like, yeah, it's kind of hard to like, because I've been trying to figure out if there's a way to fully upstream Kind. Is Kubernetes is very, very heavily tied to the behavior of etcd. So it's not like it needs there's no formal definition of the requirements of the storage backend. Basically everything we did with Kind, we reverse engineered. It was just a lot of testing. It literally took about like 3 years of on and off development to create Kind to the point that it was really scalable and good. And at this point, it's pretty darn rock solid. Like, so the thing that's kind of weird is like in order for us to upstream and actually get things baked in directly into Kubernetes, is we kind of first have to come up with like, what's the definition of the storage interface, which doesn't actually really exist today. So it's kind of going to be a pretty long effort to be able to do that. And there's not enough push right now, because like we created Kind and we use it in K3s and it's very successful. But I personally have been like, anytime I can talk about Kind, I try to push it out there, trying to get more projects to use it. So I know like some hosting providers have actually picked up Kind as a way to more efficiently run managed Kubernetes. Like they're not running K3s, just Kubernetes. Managed Kubernetes, they can more efficiently manage the data stores. It's cheaper and more scalable. But so if I can get my plan is here's like, if we just get more people using Kind and show that there's enough people who do care about alternative data stores, then maybe we can upstream it. But it's been a very long going effort, and it kind of got stopped years back when upstream just said like, well, just implement an etcd shim, and they don't, they kind of stopped there.
Okay. Do you have plans on supporting any more different database backends with Kind?
Yeah, well, so the two that have come up that people care about. Well, okay, so I know some people who are experimenting with Cockroach. That seems to be been going pretty well, but I haven't heard that it's gone into production yet. But Cockroach doesn't require any specific integration into Kind because it's already I think Postgres based API. And so we just support Postgres. So the other ones is SQL Server and Oracle are the two databases that we've asked, people have asked for. SQL Server is probably the higher priority one. So there's already PR out there, and I'd love to see they get that in there, because we can, if we get that merged, then we can, not that, I don't know if this audience would care, but we could actually run Kubernetes fully on Windows, no Linux nodes, which like nobody's able to do right now. But we would be able to do that.
Yeah, that's fantastic. There was actually some conversation in the chat earlier during the talk about Windows support. So it sounds like that's part of the puzzle.
There's been various, a lot of various developers and stuff. A lot of them at Microsoft have gotten K3s running on Windows in different ways. We don't have first class support for it. I'd love to see that happen, but there's like, it's always like it's like the container support on Microsoft or on Windows is like kind of this moving target of, there's always like the next release. I mean, not that they aren't fixing things, they are fixing and doing an amazing job, but it's always like, oh crap, we hit that one. Okay, now the next release we'll get that. Oh crap, we hit something next. So it's been kind of like,
they're playing catch up.
Yeah. So it's like Windows is very far behind where Linux, but it's like it's getting very close to being there. Okay. So we should, I hope to see that. But in terms of like, if you just want K3s, like the Linux version, K3s and WSL2 is amazing. That works just seamlessly off. When WSL2 first came, like when they first announced it, we worked with Microsoft on getting a couple configuration and patches and whatnot into the kernel to make sure that the kernel would support K3s. And so it just works seamlessly. There's a lot of people running K3s and WSL2.
Oh, fantastic. This one strangely doesn't seem to be very K3s specific, but maybe using the same sort of techniques. Would it be possible to embed QEMU and or libvirt within a static Go binary like K3s? So I don't know whether it just means about using the same sort of technologies to package them together.
Yes, there is, but there's you might want to check out this. Oh crap, what is it? Containers. This pretty cool project. Oh crap, what is it? libkrun. This is a brilliant project that basically, it's not complete. This is very experimental, very, very new. A couple engineers at Red Hat are working on this, that basically turns kind of the Linux kernel in a VM into like a library. So you can just make a couple like library calls and create a VM, and it boots a VM amazingly fast. And it requires no special privileges or anything. So it's like think of it as like and it also shares the file system too. So it's like chroot on steroids. It's actually a VM.
Wow.
This is so this is a different, because I just love virtualization and containers and technology in general. And so when Firecracker came out, and that Firecracker is all written in Rust, and they wrote their own VMM in Rust, and then the community really embraced it, and now you have like the Rust VMM projects. And so this is built on a lot of the Firecracker stuff that came out of it. It's like there's a lot of really cool stuff going on in the Rust world of doing VM type stuff. And the guy, this guy here, SLP, I don't know what his name actually is, Sergio. On his, I think it was on his Twitter, I saw he got this running on an Apple Silicon. It was an Apple Silicon or just Mac OS. Anyways, he got it working with the Mac OS. I think it was on Silicon. But he got it working with the hypervisor framework in a Mac or whatever. So it's like running Linux containers on a Mac. It's blazing fast and amazing, but it's way early. There's issues with networking and storage in it. But anyways, if you're interested in those things, check out like that project and start poking around in the Rust world. But if you want to go a completely different route, there's something like KubeVirt. So you can just package KubeVirt with K3s really easily. Like Rancher has this project, Rancher Harvester. Let's see if I find it. Which is basically like building a VM a VM hyperconverged framework. This is built on K3OS, K3s, KubeVirt, and some other custom controllers and whatnot. And you can just run VMs really easily. So this is this is like basically open source alternative to vSphere and Nutanix.
Cool. I've got one more question for you, and then the rest are more aimed at Civo. So you're welcome to then either head off or hang around if you wish, whatever you've got time for. So the last question is, how come traffic is used for ingress over Nginx?
Yeah, well, so originally where that first came from was at the time when we first started this, Nginx did not support ARM v7, which we needed for the Raspberry Pi. Raspberry Pi is now going like fully 64-bit. Well, not fully, but like they have 64-bit. But yeah, because of the Raspberry Pi, we've always maintained in K3s ARM v7 support, and Nginx the Nginx controller did not have it. It's not Nginx itself; it was the Nginx controller was not offering support for that, and so traffic was our only option. But now that we've gone with traffic, we then look to switch away from traffic onto Nginx, because Nginx now, the Nginx controller does support ARM v7. So we looked to switch from traffic to Nginx, and we got very big pushback of people liked the Nginx one. And so there is now a particular advantage of sticking with traffic is we are now looking at moving to traffic v2, and traffic v2 is going, like, I believe this is true, is implementing or has already implemented the new, is it called Gateway API? It's kind of like Ingress v2 in Kubernetes. There's a new set of layer 7 routing APIs in Kubernetes. Maybe it's the service API. I can't remember. But anyways, but they're implementing that. So like by sticking with traffic, we get like a single binary, very lightweight. The performance is good. And traffic 2 is even better. It's like we just haven't switched from traffic 1 to traffic 2. And so I don't know, we've worked, we've always had a good relationship with that project. And so we've just kind of stuck with it. So yeah, that's kind of where we are. But you can disable it and then just put Nginx in if you want. So you just do -- disable traffic, and then you just put in your own Nginx controller.
Cool. Are you heading off, or are you hanging out for the last
I'll hang
5
out.
questions?
I'll just sit here. I'll stop sharing, and then I can go on mute here, and I'm curious to hear what people are asking.
Cool. So the first question actually relates to the last question I just asked Darren. Do we have any plans to change the default traffic in Civo's managed K3s service? So the answer really from our point of view is that no, we tend to try and stick as closely as we can to the default K3s. We want the principle of least surprise. If you're used to using K3s on your own VMs or your own computers, we want you to be able to use the managed K3s service in exactly the same way. So when Darren and the guys at SUSE replace it with traffic 2, or if they ever change their Nginx, then we would change as well. But no, we tend to stick as closely as we can to the defaults. Now that said, as Darren just said, you can change it anyway. So within either our CLI or within the web interface, you can uncheck traffic and check the Nginx controller, and it will replace it when you install your cluster. So we kind of have a way to change it nice and easy with a couple of clicks, but we don't plan on deviating from upstream. How can we set storage and security for our container deployments to Kubernetes? We give you the full the full kube config that we get from K3s. So if you want to set any pod security policies or anything like that, you can do that from the same admin key that you'd normally use. We don't have any other kind of options in the pipeline for that. What made Civo choose K3s for its managed Kubernetes service? Well, this started off because we were actually using Deis, one of the companies that Darren mentioned earlier, to host the first versions of the Civo website on. And we had a couple of problems with it, and the website went down. We tried reaching out to the community for support and find out what's going on with our Deis cluster, and had minimal help. So it was just wipe the cluster, reinstall, restore from backup. We then come across Kubernetes and thought, this is awesome, but spending 20 minutes waiting for a cluster to build just feels horribly slow. And at the time, K3s was the only ones out there really that was doing it in such a way that we could launch these quickly for customers. I think from my point of view, I probably have the mentality of a child. I want something and I want it now. I don't want to wait. So being able to launch K3s clusters on our infrastructure in under 2 minutes was sort of a great goal for the time. We were aiming to get it faster, but that was sort of at the time. I can wait 2 minutes. If I've got an hour lunch break and I want to play with something in Kubernetes, launching a cluster in 2 minutes and having 58 minutes to play is much better than launching something in 20 minutes and only having 2/3 left. That said, I would still stick with K3s, even if we were starting now. I know there's micro K8s and there's K0s, but it just feels that Darren and the team at SUSE's decisions on, they want to be opinionated and they're trying to cut things down. The amount of work that they've submitted back to upstream Kubernetes as well. So this isn't just we're maintaining a massive set of patches and it's our stuff. Darren's approach to actively trying to get these accepted upstream fits in very well with our philosophy of, we want to make things better and contribute back to open source rather than just take. So that's kind of a company ethos we have. What use cases have you defined for K3s for Civo, and what have customers been using it for? So this is more about our managed K3s service. Because we currently only support a single master, we're advocating it for sort of dev, test, experimentation environments, and CI/CD runs, things like that. So we've had customers that want to test their applications on a Kubernetes cluster, but rather than keep one up and running, we can launch the cluster very quickly and deploy your application, run any integration test you want, and then tear the cluster back down again. When we launch multi-master K3s support, which is planned on coming in the next few months, I believe, then sort of we would advocate more for production as well. But for the moment, we're not advocating production purely because we have a single master. What's the latest news on the new platform and the US region and other forthcoming regions? Wow. Okay. The new platform is proceeding very nicely. It's due to be going live this month. So we've had a lot of problems with OpenStack recently, involving both capacity and some sort of bottlenecks we've found within the system. So our new platform is being built entirely from the ground up, Kubernetes backed. So as Kai said earlier, it's turtles all the way down. And we're almost at the point where it's ready to actually start getting into customers' hands. So the hope is that we should get it in customers' hands this month, maybe sooner than the end of the month. Keep your eyes peeled on our Twitter feed. That will be immediately going live on our new US region. So we have open compute hardware out in New York City. I think it's just outside New York City, but in that area of the US. And we're working hard to get our new cluster built on there and upgrade our website to be able to launch resources in there. Regarding other forthcoming regions, I'm assuming this question has been past our CEO and I'm not about to suddenly give away the world. Quickly check Slack with another window to make sure the CEO is not jumping up and down saying, no, don't say anything else. So I believe the next region is going to be the UK, which is going to follow on rapidly after the US region. We started off as a UK-based cloud hosting provider. So we want to make sure that sort of while we're launching in the US to launch a second region, our next one has got to be bolstering our capacity in the UK. And then after that, we'll be launching in a third region, which will probably be the India area, before sort of solidifying in each of those three regions before branching out even further over the next few years. Just going to check to see if there's any other questions. Okay, so the next question, excuse me, is there a timeline for adding the ability to customize the K3s options when we launch K3s clusters at Civo? So launch a cluster under a managed service, but customize the API server arguments, for example. The honest answer to that is there's no plan for us to do this. Now, that said, it's actually relatively straightforward for us to do. So if you go to civo.com/account/suggestions, if you suggest this and there's other people that are interested, as a company, we tend to try and work on things in the order that our community wants them. So things like this, if you can create a suggestion, maybe share it in our community Slack and get some other people to vote, then it will get bumped up the priority list. But I'm all in favor of features that are quick to add and desired by the community. So that's sort of my answer there. Unless there's anything else coming, Kai or Ricky, that you've seen that I haven't spotted?
No, I think you pretty much covered everything, Andy.
Fantastic.
Excellent.
So I'd just like to take the time then to thank Darren again for joining us today. The 30 to 45-minute talk went on longer than probably he predicted and his team would like, but it's been absolutely wonderful and so much great information for us. So really appreciate your time today.
Yeah,
Thanks,
thank you.
Darren.
It was fun.
Cool.
Oh, since Darren is still here, we've got a last one quickly. Since Darren is still here, thank you so much. Amazing deep dive. Absolutely agree. Have you tried running K3s on micro OS?
Yeah, I don't think there's any issue. I'm trying to think. I don't know if I have. I mean, because I've definitely run on most every other SUSE thing. I don't know, but I can't imagine there's going to be any issue there. Yeah.
Cool. Okay. Right. I think that calls it a day. So thank you very much, everyone. Thanks again, Darren. And yeah, keep your eyes posted for the next webinar.
Yeah, we should be doing one in about a month.
Yep. We'll keep you all posted on that. Thanks, everyone, for joining us.
Brilliant.
Thanks for tuning in.
Cheers.
Bye.
Thanks, everyone.
Bye.